Up to now, we have discussed the operations to save data to a file and to load the data from the file. And those operations are done in one function call or in one MATLAB command. And those operations are usually called high-level file operations. And this is because they are done in one step. However, underneath, there are three basic steps. And we're going to discuss each steps in details. Before we start, we need to get to a few terms. The first is called read. What is read? Well, it is to get the data from a data source to the program. In this example, for example, the data is stored in a disk. Then, behind the scene, the electronic circuits read the data in a form of a string of binaries, 1010s. And then it's sent to the software to process it. The software will use the knowledge of the data format to interpret the bit string into a meaningful data to process. The write operation is just the opposite of read. The data starts from the program, for example, in this case, a MATLAB program, and then it will generate the data in a string of binaries. And the string of binaries is sent to the disk for storage. Every file has a file name. In MATLAB, the file name can be a character vector or a string. If the file is not in the current folder or the folders in the search path list, you need to include a path to the folder where the file resides. Usually, the path contains /. However, / is an escape symbol and has special meaning when combined with the following character. For example, /m meaning new line. Therefore, you need to use double / to represent a true single / in the string or character vector. Here is an example. If the path is h://matlab/ data.mat, you should rewrite it as h://matlab/ data.mat. This is very important in other programming languages such as C and C++. However, recently, MATLAB made some changes. You can use single / directly in the path. Therefore, you can use h://matlab/ data.mat as a full file name of a file, and it will not have any issues. Before I start talking about the steps of file operation, I would like to use an example how to access a file in a traditional file cabinet. In this example, if you want to find a file in a cabinet and find the information in that file, what you're going to do is go to the cabinet, open the drawer that contains that folder, and then you find that file. And then you take it out, put it on a table, you open the file, and then you start to either read the information on the file, or you're going to write down some new information into that file. And once you're done, what you should do is to close the file and then put it back to the cabinet, and that's done. So, in a file operations in the programming, what are the three steps are file opening, file reading or writing, and file closing. So first, we will use a file open function to open a file. What it requires is a file name and also some permissions how to operate on the file. So what you'll get is a so-called file ID. And this is a number. And once you open a file, and the following operations will no longer use file name. Instead, it will use a file ID to identify the file you're going to use. And once you open the file, data can be written to or read from the files in two possible ways. One is called a binary file, and the other is formatted character data. And in essence, those two forms are essentially the same, except that the formatted character data set already gives you the idea of how the binary data is organized or is formatted. And lastly, when you're done, you need to use a function called fclose with the input variable of a file ID to close the file. And this is very important. It's just like you are working with a regular file from the file cabinet, you need to put it back. If you don't do so, your desk will pile up with all those open files. It will be a mess. And for computer programming, if you don't close a file that you already done, it means it will still use the resources, the memory resources. And if you keep opening files and without closing any of them, and eventually you will crash the program. Here are the general forms of the fopen function. The first form is the simplest one, and it has two input data. One is called file name, which is a string specifying the file name. And the second is a permission, which is also a string specifying how the file will be used, whether it will be read or it will be written. And the function will return the file ID. The second form of the fopen function is almost the same as the first form, except that it will return two data. One is still the file ID, and the second is a message. If the file open operation is successful, there will be no message. Otherwise, you will have an error message, which is a string. The third form is a bit complicated. It is a slight different from the second form, that it needs a format as the third input. So of course, the file name is a string specifying the name of the file to open, and it can also include the path in the file name if the file is not in the current folder. And the permission itself is also a string that specifies the mode in which the file is opened. In other words, whether it's open in read mode or write mode. And if its opening is successful, the FID will contain a positive integer and the message will be an empty string. And here is where the information, which is very important, is that if the file ID is not a positive integer, for example, if it is a negative value, usually it's a -1, this means the fopen operation failed. And you can use that number as a judgment to see whether the file operation is successful or not. The table for the file permission of the fopen function. The letter R represents to open an existing file for reading only. And this is the default setting, which means if you don't specify that as a permission, then you're going to open the file for reading. The letter W, it will delete the content of an existing file if it already exists, or it will create a new file. and then it will write the data to that file. So, in other words, if the file already exists, it will be overwritten. And there are also other options. And for this course, I will focus only on the two operations. One is to read, and the other is to write. And you may have a question like, can I open a file for read and write at the same time? Well, the answer is yes. However, it is highly discouraged to do so. And it is because this is not a good practice and will cause confusions in data operations. And quite often, you will corrupt the file. This is a table of format string for fopen function. I have to point it out here that there's a typo in the textbook. And this is the table from the textbook. And it should say file format instead of file permission. The default format is native, and it is used by MATLAB. And I don't think you need to change that. And all the other options are very specific, and unless you have a reason to use it, otherwise try to avoid using the other format, because that will add a level of complexity when you try to read data back from a file. Function fclose closes an open file. It requires file ID as the input. Sometimes you can use a character vector or as the input. In that case, it will close all open files. The function will return a status. If the status is 0, the operation is successful. Otherwise, it is unsuccessful, an error occurred. File handle 1 and file handle 2 are special file handles. They represent standard output and standard error output. In MATLAB, they both map to the command window. Therefore, if we use fclose or, it will not close either file handles. So those two file handles are always open. After we open the files successfully using the fopen function, we're going to do either to write the data to the file or to read the data from the file. The fwrite function writes binary data in a user-specified format to a file. It has a form as follows. And it needs 3 input data. The first one, FID, is the file ID obtained from the file open operations, that is, from the fopen function. And the second input is data to be written to the file. It can be any array. And the third input variable determines the format of the data. So the precision here is the third input. It has to match the format of the data in the array. And the count is the number of values written to the file. For example, if the array has 100 data in it, so the count should be 100. So MATLAB writes data in column order, which means that it will write the first column first and then followed by the second column and so on and so forth. If you remember the storage of the array in memory, you probably will recall that any two-dimensional array is stored by column. So that's why when MATLAB writes data out to a file, it follows the column order. Here is a table for the precision strings for the fwrite function. Here are the strings that's supposed to be used in the fwrite function. And here are the meaning of those strings. For example, for the first precision string, it's called char. It means the data is formed by 8-bit characters, so it can be used to describe a string. And if the data is double precision number, you should use float 64. We use function fwrite to read data from a file. The fwrite function reads binary data in a user-specified format from the file. And it has a form like this. And it has 3 input data. The first is FID, which specifies the file. And the FID is from the fopen function. And next is the size. And it specifies the amount of data to be read from the file. And this is optional. If you don't specify the size, the fwrite will read the entire data. And the third input is called precision. And this is very important. It will affect how you interpret the data read from the file. And if you specify the wrong precision, the data will be corrupted. And so, before you do the fwrite, you must know that the data format on the file, or in other words, how the data is organized on the file. And this is related how the data is written to the file previously. So what you get from this function will be 2 outputs. One is for the array that holds the data, and the other is called count that returns the number of data read from the fwrite operation. So what happened if the size is greater than the file size? And here is how the fwrite function will do. It will pad the last byte or element with 0 bits so that it will fill up the array with that specified size. And this should not happen, because if this happens, something is wrong. So you need to avoid this to happen. And one way to do it is to make sure you have the correct size of data points in that file before you do the fwrite. In order to show the importance of the precision input to the fwrite function, I'm going to use double precision floating point format as an example. A double precision floating number uses 8 bytes of binary, or 64 bits. The 64 bits are divided into 3 groups. First, bit 63 is used to represent the sign of the value. If it is 0, it means a positive value. If it is 1, it means a negative value. You can see it in the equation below. The next 11 bits will be used as an exponent. It is an e-value. So you can see it in the last item in the equation. The rest 52 bits are called fraction, and they are used in the middle term inside the parentheses. Now I'm going to use value 1 and to see how it is expressed in the double precision floating point format. And here are all the bits in the double precision format. I use color match. So the first value is 0. It means that it is a positive value. The next 11 bit in green, if we convert the binary into decimal, it will be 1023. And then if you go back to that equation, you will know the last term will be 1 because e minus 1023 will be 0. So 2 to the 0 will be 1. The rest of the binaries are zeros. So if you look at the midterm, and you will see that the value of sigma will be 0. So the value inside the parentheses will be 1. So with all that, we know that this code will represent value 1 in double precision. If we use a decimal to represent the values of the 8 bytes, and here are the values we get. It will be 63, 240, and 6 zeros. Now let's see what will happen if we specify the wrong precision input in the fwrite function. And we just store a double precision value of 1 in the file. And now we're going to read it back in the single precision floating format. Let's see how it happens. The single precision floating number uses 4 bytes of binary, or 32 bits. And you will see the 32 bits will also divide it into 3 groups, with sign, exponent, and fraction. However, if we try to read it back as a single precision number, MATLAB will group the data in 4 bytes a group, because the 4 bytes will be one single precision number. So the 8 bytes of double precision number will actually be divided into 2 single precision floating numbers. So after we read the first 4 bytes, then the MATLAB will interpret it in a single precision format. And easily, when you look at the number that is read into the memory, and here I just put it as the first 4 bytes, and then turn them into the binary and use the same color code. And if you do the same exercise, you find the sign, which is positive, but the exponent will be different. And so is the fraction. So if you plug in everything into that equation, the value will become 1.875, which is totally different from the value of 1. And that is a corruption of the data. After we got the 8 bytes of data in the previous slides, there's a question of how to store those bytes in a file. There are 2 ways to store the 8 bytes. The first is called little endian format. It's a default in MATLAB. It will store the least significant byte first. For example, for the value we just got in the previous slides, the order of the bytes is as follows: 0, 0, 0, 0, 0, 0, 240, 63. It's just a reversed order of what you just seen in the previous slides. Alternatively, you can specify the so-called big endian sequence or format. In this format, the most significant byte will go first. And for the same example, you will see the exact same sequence we got in the previous slides. Now the question is, how to choose the 2 format? Well, remember when you use the fopen function, there's an input called format. If you don't specify any format, it will be as a default format, that is little endian. And if you specify other format, then it can be either little endian or big endian. So just for simplicity, we don't specify that, so we know that the format will be little endian.